Mechanical metronomes use a weight that is adjusted along a rod to change their tempo. The time in seconds that it takes for the rod of a mechanical metronome to swing can be described by the function t of x equals 2 pi times the square root of x divided by 9 and 8/10, where x represents the distance in meters between the weight and the fulcrum and the base of the metronome along its rod. Metronome speeds are described in beats per minute, or the number of swings per minute. A piece of music is to be played at 70 beats per minute. How far from the fulcrum and the base of the metronome should the weight be placed along the rod to time this piece of music? Use a problem-solving model that includes analyzing given information, formulating a plan or strategy, determining a solution, justifying the solution, and evaluating the problem-solving process to write an equation whose solution answers the question and use the graph to solve the problem. Okay, so first just analyzing this information, then it gives us first an equation that where t of x is the seconds that it takes for the rod of the metronome to swing, and then x is going to be the distance between the weight and the fulcrum and the base of the metronome along that rod. And so it tells us then down here if there's a song at 70 beats per minute, and so that would be related to t of x, which is the time it would take, then how far should the weight be placed along the rod from that fulcrum, which we just saw was x. And so from that question, we're going to be trying to find x. We don't have that, and we do have almost t of x, the time in seconds, but the key here is that it's in seconds, and this one's 70 beats per minute. And so we need to convert this into seconds. So if it's for every 1 minute, if it's 70 beats, then we can use another ratio to convert this. And so we know then that 1 minute is related to seconds because 1 minute is equal to 60 seconds. And so we match that diagonally, so we can put 1 minute on the bottom, and then we know that that is equivalent to 60 seconds. And so then those units essentially cancel, and then we get, if you multiply straight across, 1 times 60 is just 60, and then seconds, and then 70 times 1 is just 70, and beats. And so we have 60 seconds per 70 beats. And if we simplify 60 divided by 70, then that is the same thing as 6/7 seconds per beat. And so using that, we can plug that into our function for t of x, because now we have the time in seconds that is equal to t of x. So we can just say, well then 6/7 equals our function. And now that we have that, then we can go ahead and use our calculator, and we can put in the one side into y1 and then put the other side into y2, and we can find where those two things intersect, and that will be our answer. Okay, so I've gone ahead and I put in 6/7 into y1, and then into y2 I put this other side, and now we can go to our graph, and we see the straight line is 6/7 and our square root line on the other side. And let's go ahead and find that intersection. So we just need to press second trace, 5, enter. And then, so first curve, second curve, you can just press enter, enter, and then enter. And we see our intersection is 0.18237,813. And then our y value, presumably there, that's the equivalent of 6/7. And so that means that our answer is going to be 0.18237,813 for the distance in meters between the weight and the fulcrum on that metronome. And if we round that off to the thousandths, that would be 182 thousandths. And if we wanted to even put that into centimeters, you would just need to move the decimal place over twice. So it would be equivalent to 18 and 2/10 centimeters as well. So anyway, let's go ahead and summarize our answer. A piece of music played at 70 beats per minute takes 1 minute to play 70 beats. Since t is measured in seconds, you must convert this measure to determine the number of seconds a single beat or swing of the metronome's rod takes. 1 minute per 70 beats times 60 seconds per 1 minute equals 60 seconds per 70 beats equals 67 seconds per beat equals 6/7 second per beat. Therefore, the equation 6/7 equals 2 pi times the square root of x divided by 9 and 8/10 will determine how far from the fulcrum the weight should be placed in order for the rod to swing at a rate of 70 beats per minute. Using graphing technology, you can determine that the weight should be placed approximately 182 thousandths meters, or 18 and 2/10 centimeters from the fulcrum, to time a piece of music that is to be played at 70 beats per minute.